Okay, so let's move on to the next page. And although, again, we did this in section 2.1, I'd like to go ahead and do this work with you. So the first thing we're asked to do here is to label the point P, which is some fixed point. That's kind of the important. That's why we're using the letter A as opposed to a variable H like we do down here. We're thinking of P as a fixed point, so it's going to be at the coordinates A, comma, f of A. Okay. And then we're asked to go ahead and label point Q with these coordinates. So let's go ahead and do so. So we've got A plus H, comma, f of A plus H. And I can barely fit that there, but we got it. Okay, so step 1 done, step 2 done. All right, so I'm going to pause the video and do these 2 steps because I have a hard time doing this on my device. So let's go ahead and pause it. Okay, so I've plotted here in red, I've plotted the tangent line at P as best I can, and here in green I've plotted, it's not quite perfect, but we've got the secant line connecting P and Q1. Okay. All right. So now I'm asking you to go ahead and again give the slope of the secant line, but now we're going to, instead of using the ordered pairs from the previous page, we're going to use this pair of ordered pairs. So we're still going to say that's going to be y2 minus y1. So I'm still going to say that we've got f of A plus H, that's my y2 value, minus my y1 value, which is f of A, all over, and here I'll go ahead and let's just write it for right now. I'll write A plus H minus A, but notice what happens to the 2 A's in the denominator. So I could go ahead and rewrite this as f of A plus H minus f of A all over H. Okay. Well, notice that we're looking at the slope of the tangent line. That's what we're trying to approximate, and our strategy is to use a secant line to approximate that. Well, at this point, it doesn't seem to me like our green line has the same slope as the red line nearly at all. Although you could argue that the red line has a negative slope, and so does the green line. Okay? But what could we do to make a better approximation? Well, let's go ahead and draw the secant line connecting P and Q2. Okay, so here I've tried to draw the secant line connecting point P and Q2 here, and notice that well, the black line still does not have the same slope as the red line. The black line has a closer slope to the red line than the green line did. So we've made an improvement. Yes, that's what we've done here. We've made an improvement by drawing this. And how could we continue to get a better and better approximations? By introducing these new points, Q1, Q3, Q4, Q5, bringing those points closer and closer to P. Well, for that to happen, okay, what do we need to do? Well, the only difference between these 2 points was to say that this one was a distance of H away. So let's go ahead and just real quick here. This wasn't something I asked you to do in the handout, but let's go ahead and put, here we had A, and then let's say for Q2, there's a Q2, we could think of that as the point A plus H, that's that coordinate. So what does that mean that H represents? H represents the distance between A and A plus H. Okay? So H is that distance, and what do we want H to do? We want H to tend towards 0. Okay? As H tends towards 0, that means A plus H gets closer and closer to A, bringing this in. So if we were to pick, say, some other arbitrary point way up here, let's put it right about right here, just say, and it's arbitrary, but there's our point Qn. Qn, maybe it also has that, we think of it as having the coordinates A, comma A plus H, but in this case H has gotten smaller. Then when we draw a new secant line here, I'm not going to because my diagram's getting a little too cluttered, but when we draw a new secant line connecting P and Qn, notice how closely that will align to our tangent line. Okay. So in this case, and not in all cases, but in a lot of them, as Qn gets closer and closer to P, we saw the slope of the secant line was getting closer and closer to the slope of the tangent line. Okay. So the big picture for this, I'm going to go ahead and let you copy this. These were in your 2.1 notes. So go ahead and fill in number 6 from your 2.1 notes. So what we see here is that as Qn approaches P, For that to happen, this ordered pair right here, which was our Qn ordered pair, needs to approach the ordered pair A comma f of A. So that's the notion of moving these Qn's. Here's Q1, here's Q2. These Q's are getting closer and closer to P. Well, for that to happen, if this ordered pair is getting closer and closer to this ordered pair, the only way that can happen is if H is approaching 0. And all of a sudden, we've now tied this into what we've been doing for the past month. So take a minute, think about number 7. We just spent the last 4 weeks focused on something else other than our tangent line question. What was it that we studied? And then I'd like you to answer number 8 on your own. In order to arrive at the slope of the tangent line of the curve at P, what should we do with this expression? And I'll give you a hint. It has to do with something that we saw up here. What should we do with this expression if we want to actually come up with the slope of what we're considering the tangent line? So this is the end of the video. Go ahead and answer number 7 and number 8, and then we'll move on to the next page.